Good day. For those of you who do not know us, we are the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to introduce a linked list with a list size member variable. So in this lesson, we're going to describe how to add a member variable to record the size. However, this is actually going to be quite straightforward. We're going to use this instead to describe and see how there are superior ways of authoring code. And we will explain how leaving an object in an inconsistent state is something that must be minimized in time for reasons of ensuring that the number of bugs introduced due to misunderstanding that inconsistent state are minimized. Currently, if we want to determine how many nodes there are in a linked list, we have to count them, and this has to occur inside a for loop. This could potentially require a significant amount of time. It should, however, be possible to track the number of nodes in the linked list with a single variable that is updated appropriately. So such a member variable should be initially set to 0, as the initial linked list is of capacity 0. There are no nodes in it. And this member variable will only ever be modified in any member function that changes the number of nodes in the linked list. This, of course, at this point includes only push front, pop front, and clear. However, knowing how our member functions are implemented, the clear member function simply calls pop front an appropriate number of times, and thus we really only need to modify the first two member variables. Now, first we add an appropriately named member variable to the class. Then in the constructor, we initialize it, in this case, to 0, as initially there is nothing in the linked list. Next, we must modify any member function that changes the number of nodes in the linked list. This includes push front, where now once we add a new node into the linked list, we also have to increment the list size, and pop front, where when we remove a node from that linked list, we should also decrement the list size. Now, note in the changes that we just made that all member variables are changed as much as possible in the order in which they were defined in the class definition and as close as possible to each other. So changes are not made in significantly different locations. This allows other programmers examining your class to, for example, become familiar and comfortable with your design. In your class definition, you have declared the member variables in a specific order, and then throughout your code, you update those member variables in the same order or as close as possible. This also helps for finding mistakes. For example, if you're familiar with these three member variables being modified when a change is being made to a class, then suddenly seeing one location where those changes are not made to all member variables, you may ask whether or not there's an issue there. Also, it helps when you're adding more member variables for additional features, because again, if you are modifying some of the member variables to add an additional feature, when you're adding new member variables, you can very quickly ask, oh, should this be where I should be changing these member variables? Also, it makes for the possibility of avoiding mistakes by having as few statements as possible that are executing that leave the linked list in an inconsistent state. Now, what does that mean? Well, an inconsistent state is when, for example, the actual number of nodes in the linked list does not match the member variable list size. Let's take a look at some suboptimal ways of authoring code. So less optimal would be just changing them as you feel like it. So this first one isn't that bad. There's only 2 statements. The code is not left in an inconsistent state, but the order in which the member variables are changed does not match the order in which the member variables are declared in the class definition, and for no good reason. In this example, we have updated the list head, but then we've gone on and executed additional code that has nothing to do with modifying the linked list. So for the next 2 statements of deleting the old head and setting the old head local variable to null pointer, therefore avoiding a dangling pointer, the list size does not match the actual number of nodes in the linked list. Consequently, someone else coming around who is modifying the code to add yet again another feature may simply add some more statements after the update of list head without realizing that the member variables are currently inconsistent with each other. You can also, if you want, group and highlight statements that are changing the state of the object so that you can ensure that in the future any reader looking at this code understands that the state is being changed in this particular section. Therefore, while it may seem that all code is okay as long as it gets the job done, some approaches are better than others. Now in this course, you're probably not going to be harmed if you don't pay too much attention to some of the guidelines suggested here. But as you go into industry, you will be exposed to other authors' code, and you may actually find that sometimes it becomes rather frustrating to read code when appropriate thought is not applied in the design. Also, programmers reading your code will be thankful, even if they have no clue who you are. And actually, you will be thanking yourself, especially if you haven't looked at your own code for over a month. I'd suggest you go back and look at some of the earlier projects from this course which you've submitted and see whether or not you actually enjoy or can understand what you were attempting to achieve at that time. And after this course is done, try looking at your 1A code at the end of your 1B academic term. Once again, try to decide whether or not someone else would appreciate reading your code. So, following this topic, you now know that adding features can in some cases be quite straightforward. And you understand that adding features that significantly reduce the runtime can actually be very beneficial. So rather than counting all the nodes in a linked list, we've now just reduced calculating the size to returning a single member variable. You understand how code changes, however, are also relevant. For example, it is critical to leave the object in an inconsistent state for as short a period as possible so that future programmers who are editing your code do not accidentally assume that the code is or the object is currently in a consistent state. Here are the references, the colophon, and a disclaimer. Cheers!